Okay, so I would like to discuss the question yesterday. Hello students, right now we are going to discuss about the questions, the second question about halogenoalkanes. This is about the chemical properties of halogenoalkanes. There are 9 pages on this worksheet. Number one, alkenes are useful intermediates in the synthesis of organic compounds. Complete the elimination mechanism by drawing the appropriate curly arrows. We know that elimination reaction is the removal of an halogen atom from a halogenoalkane. So the process is the reaction is halogenoalkane becomes alkene and then plus water and then plus the profile of the halide ion. Okay, the mechanism here we have to complete. There is a lone pair DOH, and then the lone pair here will attract the hydrogen. The hydrogen, the electron of the hydrogen will be taken by the middle carbon. That makes the carbon will become an carbocation. Because the carbocation, there's the carbocation, and this electron from this carbon also taken by the bromine. That making there are two carbocations in the intermediate. Because there are two carbocations, the carbocations is due to the one electron in the p orbital is being taken. So the electron from one p orbital in one carbon overlaps with the electron from another p orbital. That makes become an overlap of p orbital, and therefore we call there is a double covalent bond. And then we have to draw the structures of E and Z stereoisomers of hex 3-ene. E and Z refers to cis and trans. E is for trans, while Z is for cis. As we can see there in the alkene, if there are two same atoms located diagonally, it is called as trans. While there are two atoms located horizontally, they are called as cis. And then next, state the meaning of stereoisomers. Stereoisomers are atoms or groups of atoms that have different spatial arrangement or different orientation. The stereoisomers can be the optical, also can be the geometrical. If geometrical, it is consisting of cis trans. If optical, then there are two enantiomers, one dextro, one levo, one on the right, one on the left, which is the mirror of each other. Number B. The equation for the first reaction in the conversion of hex 3-ene into hexanol is shown below. This is the first reaction. Okay, first reaction conversion when alkene react with sulfuric acid to become sulfonate. So this one, the same, the mechanism is called as electrophilic addition. The high charge density of the carbon-carbon double bond repels the electron in the hydrogen. That makes the electron in the hydrogen is taken by the SO 2 minus 4 HSO 2 minus 4. Okay, so there is a high charge density that makes the hydrogen becomes an electrophile, and there is a lone pair here in the O that can make the covalent bond with the carbocation. Okay, and then how many different alkenes are formed when 2-bromo 3-methyl-butane reacts with ethanolic potassium potassium hydroxide? There must be 2, and then uh, one is the major and the other one is the minor. The major is according to the formula, according to the theory of the Markovnikov's rule. Okay, in 2-bromo 3-methyl butane, there are 2 possible products. We know that there is a major and there is a minor. If we draw the structure, that there would be 2 different reactions. Okay, so we know that the location of the bromine is located at carbon atom number 2. So this one can be 3-methyl but 2-ene. Okay, and then also can be in the carbon atom of the other one, because the location of the double bond is located in carbon atom number 2. Okay, now number 3, nucleophiles react with bromoethane in substitution reaction. This type of reaction is illustrated in the following scheme. So there is a halogenoalkane. Halogenoalkane undergo reaction 1 to become propane nitrile. The catalyst, the reagent is KCN, and then this one halogenoalkane reacts with potassium hydroxide to become ethanol, which is a nucleophilic substitution. And then for the reaction 2, it is also a nucleophilic substitution because the bromine is displaced by the presence of NH3. Okay. Now let's see what the question is. Number 1, state what is meant by nucleophile. We know that nucleophile is a group of atoms or an atom that has a lone pair, and the lone pair can make a active covalent bond with the carbocation. Now the B, outline mechanism for the reaction of potassium cyanide with bromoethane to become propane nitrile. This one, because the electron of the CH2 is taken by the bromine, because bromine is very electronegative element, so the electron can be taken, and then the Cn negative has a lone pair. The lone pair can be donated to the carbocation. reaction by making dative covalent bond, and then that mix become propane nitrile and bromide ion as the nucleophile. C. Explain why an excess of ammonia is needed in the reaction to produce a high yield of ethylamine. Ethylamine is a nucleophile. Ethylamine could make a secondary or tertiary amines to make reaction with ammonia. Okay, it is in order to minimize the further substitution. Further substitution, what does it mean? It become salt. And then ammonia, because and also ammonia has a lone pair. Because of the presence of lone pair in ammonia, that makes ammonia can act as a nucleophile and also can act as a base. Okay, and then here D. When potassium hydroxide reacts with bromoethane, ethane can also be formed. Name and outline a mechanism for this reaction. We know that when there is a potassium hydroxide concentrated reacts with halogen alkane, this is called as elimination reaction. Okay, so the mechanism is called elimination, and then this one, the mechanism is the lone pair in the OH minus can make a dative covalent bond with the hydrogen, because the hydrogen electron is being taken by the carbon. Why is it taken by the carbon? Because the carbon itself, electrons, is taken by the bromine, because bromine is the most electronegative element. Is an electronegative element. Sorry, it's not the most, but it is an electronegative element. That makes the carbon has a empty p orbital, and then the other carbon has also same empty p orbital, or it is considered to be half filled. In order to make themselves become stable, so these two p orbitals of the two carbon atoms, they have to overlap, and then they make a new bonding, which is called as pi bond, or called the double covalent bond. Next, number 4. Consider the following reaction. When there is a halogenoalkane reacts with potassium hydroxide, this one will become an alcohol. Okay, and we have to see here. We have to see here that this halogenoalkane is a tertiary type. Why is it tertiary? Because the number of hydrogen attached on the carbon next to the halogen is 0. That means there are this one is secondary halogenoalkane because there is only one hydrogen attached on the carbon atom that is bonded to the halogen, and we know there are two alkyl groups. These two alkyl groups makes the reaction of the elimination, makes the reaction of the alcohol still possible. This one, the alcohol type, is called also as the secondary alcohol. And then the side product is potassium bromide. The reaction is called as nucleophilic substitution because the bromine atom is displaced by the hydroxide OH. Now let's continue. Name the halogenoalkane in this reaction. The halogenoalkane name in this reaction is 2-bromopropane. Okay. Because the bromine is located at carbon atom number 2. And then identify the characteristic of halogenoalkane molecule that enables it to undergo this type of reaction. It is because of the negativity of the bromine. Although it is not the most electronegative element, but bromine has some electronegative compared to carbon. That makes there is a polar bond, or there is a slight permanent dipole forces. There is a dipole positive and there is a dipole negative. Carbon will make a dipole positive and bromine will make a dipole negative. And then B, an alternative reaction can occur between this halogen alkane and potassium hydroxide as shown in the following equation. We know this one is the secondary halogen alkane, and then the reaction, because it is using the potassium hydroxide, so using 2 potassium hydroxide, there are 2 effects. One is elimination and the other one is the alcohol. What is the difference? You need to put attention on this. If there is a certain condition on the halogen alkane, in the halogen alkane and also in the potassium hydroxide on the alkali, if aqueous alkali, then it will become alcohol. If concentrated, it would become the alkene. Okay, and then this is an elimination reaction. Okay, eliminate from the halogen alkane become an alkene. Okay, this is the same as you can see here is using KOH, still using KOH. This one also using KOH also, but different product. In elimination, it is high concentrated. As I told you, it is not very dilute, and then it has high temperature or reflux with the ethanol solvent or alcoholic solvent. And then alkene can be polymerized to produce polyalkenes. It is called as addition polymerization. Next, name the alkene that gives a polymer with the repeating unit shown below. There are 4 carbon atoms here. The double bond must be located between these 2 carbon atoms. So that's why it is called as trans-butene. It is not cis-butene. Based on the structure, it is a trans-butene. Let's move to page 6. Organic reaction mechanisms help chemists to understand how reactions of organic compounds occur. The following conversions illustrate the number of different types of reaction mechanism. When 2-bromopentane reacts with ethanolic KOH, 2 structural isomeric alkenes are formed. Okay, 2 structural isomerics are formed. What are those 2? Name and outline the mechanism. It is elimination reaction. It is from the bromoalkene become an alkene. And then this is the mechanism. The reaction, the OH minus, there is a electron. The lone pair electron can make the covalent bond with the hydrogen, because the hydrogen electron is being taken by the carbon. The carbon electron is being pulled by the bromine, by the halogen. And then there is an overlap of the p orbitals. Draw the structure of other structural isomeric produced when 2-bromopentane reacts with ethanolic KOH. There are 2 as the major and there is the minor. The major will become the pentene, and then in the minor will become pen-1-ene, or called as pentene. following conversion. So this one, there is a CH3 CH2 double bond, and there is a CH3. We see here from the structure, the longest backbone, there are 3 carbon atoms, and there is a middle. So this is called as methyl propene. Reacts with bromine molecule, it is undergo electrophilic addition, and then this one will become 1.2 dibromo 1.2 dibromo, then 2 methyl propane. The mechanism, as I told you, there is a high charge density. Of course, you still remember about the reactions of the alkenes when it is reaction of electrophilic addition of alkenes. And then now C, name and outline a mechanism for the following reactions. It is the bromopropane reacts with ammonia to form propylamine. Then this one, we have to draw the mechanism. The mechanism is called as nucleophilic substitution because the bromine is being replaced by the presence of NH2. And then here the mechanism, there is a lone pair in the ammonia that can make active covalent bond with the carbonation. Because the carbonation occurs, the electron in the carbon is being taken by the bromine. And then now we are almost done with the discussion. Number 6. A student read the following passage on the internet. Halogenoalkanes contain a polar covalent bond. The carbon atom of the polar covalent bond can be attacked by nucleophiles. The nucleophilic attack enables the halogenoalkane to undergo substitution reaction. A nucleophilic substitution occurs when a halogenoalkane undergoes hydrolysis. Hydrolysis means the reaction using aqueous water, so become an alcohol. The rate of hydrolysis of the halogenoalkane is influenced by the carbon-halogen bond enthalpy. Where do we find the carbon-halogen bond enthalpy? From the data booklet. Again, number A1, we have to define what nucleophile is. You already know from the previous number. And number 2, substitution as applied to nucleophilic substitution in halogenoalkane. Replacement of the halogen by the nucleophiles. The carbon-halogen bond break and forms with the nucleophile between carbon and the nucleophile, because the nucleophile contains a lone pair that can donate the electron to the carbonation. And then hydrolysis. Hydrolysis is the splitting of a large molecule by using water into 2 smaller molecules. And then bond enthalpy as applied to carbon-halogen bond. Energy or enthalpy required at constant pressure to break carbon-halogen bond. It is the also energy needed to do the homolysis of the carbon-halogen bond. Okay, now let's continue to the last page. Outline a mechanism for the nucleophilic substitution reaction in which 2-bromopropane reacts with potassium hydroxide to form propan-2-ol. So this one is propan-2-ol. This is the propan-2-ol. So the formation of propan-2-ol from the to bromopropane. This is, we know it is a nucleophilic substitution, as we discussed on previous numbers. And then this one, halogenalkane can undergo an elimination reaction to form an alkene. So halogenalkane become an alkene, we discussed also previously. Okay, so this is the discussion of the worksheet. Okay, students, I already discussed this one, yesterday's worksheet. I know that most of you are studying physics for this forecast paper 2 at 11 o'clock. Let me ask Angie. Hello, Angie.
Hello, sir?
Yeah, Nicholas, are you studying
there?
physics? Or have you done?
No,
Oh,
I'm not going to take physics. I'm going to take chemistry and biology.
Oh, you take chemistry and biology. Okay. So for this one, for the AS level and for A level about the worksheet 2, is there any question? Nicholas, you have any question for the review of this one?
No, not yet.
No.
I think I got most of it.
Yeah, good. It's very good. And then let me ask. Let me ask to. Let me ask. Who ya? Let me see the participant. How about from Angel Honey? Hello, Angel.
Yes, teacher. Yes, teacher.
Yeah. Do you have any question?
Halogenalkane.
Yes. About halogenalkane, is everything clear, or everything becomes not clear?
I'm not sure.
Oh, you're not sure. Okay. Then let me ask to Kalista. Hello, Kalista. Kalista, are you there, Kalista? Oh, Kalista seems studying for physics. Okay, so for this one, halogenalkane, we had done so many worksheets for halogenalkane. Next week, I'm planning to have the test for halogenalkanes, but for sure will not be on Monday. Probably on.
Test for halogenalkane.
Yes, test for halogenalkane. So for maybe on Thursday or maybe on Friday. Okay, because I still have some more worksheets for us to discuss.
Teacher, for A level or AS only? I mean, who's or
I think for halogenalkane, this one start from halogenalkane. I think for AS level.
AS level.
Yeah.
So A level don't have test, right?
No. Do you want?
No, I don't want.
Test.
Yeah.
Oh.
Halogenalkane is It's not difficult. You have ever done
Oh no.
before. Right, Winston? You have done this hallucinoalkan before. So what is the problem if repeat again for hallucinoalkans?
Just the reaction, like the mind
Okay.
Yeah.
and the reaction stuff.
Oh, okay. Then for this one, I think all of you are still busy with this one physics. Give me 8 more minutes. Maybe we can end later earlier so you can have time to study. So for uh, before the class end, before the class ending, let me take attendance. This one, let me take attendance. Okay, Angie is here. Angel, Audrey A, Audrey D, and then uh, Brandon, Kalista, Celine, David, Devin, Adeline, AU, Evan, then Jalen, Jocelyn, then Justin, Kevin, Luisa, Jet, Michael, Michelle, Angelica. Oh, Michael Angono is not here. So I can see Michael Angono, and then Peter. I don't see Peter. Yeah, Peter is not here. And then let me see, is there any, is Hansen here? Oh, Hansen is not here also. Hansen is not here. Okay. Hansen is not here. And then Peter was also not in the online class. Okay. So take pendants, this one. Okay. For this one, for this one, for hallucinoalkans, the main point you should be able to differentiate between the reaction of nucleophilic substitution and also the elimination. And then the reaction mainly for hallucinoalkan is nucleophilic substitution. It never undergo electrophilic substitution or electrophilic addition, or also free radical substitution also cannot be nucleophilic addition. It's always nucleophilic substitution. Okay, for the nucleophilic substitution, the reaction must require alkali in the aqueous state. For elimination, the alkali must mix with the ethanol. And then all of you already know the mechanism. I have told the mechanism frequently for the nucleophilic substitution and also for the
Elimination.
elimination. Yes, elimination. I hope you still remember from hallucinoalkan become amines, and then hallucinoalkan become alcohol, hallucinoalkan become alkenes. Is it possible for hallucinoalkan to become an alkene?
Hallucinoalkan to
Alkene.
Alkene.
Yeah.
Alkene single covalent bond.
Oh, alkan.
Yeah, alkanes.
No, that's irreversible, I think.
Yes, correct. So it is not possible to have the reaction halogenoalkanes become alkanes. Okay, so there is no straightforward reaction, and then alkanes history. It's what is the intermolecular forces in halogenoalkanes?
Intermolecular, polar.
Yes, polar. So, what is the intermolecular forces? Is it permanent dipole or instantaneous dipole
Permanent.
or hydrogen bonding?
Permanent and instantaneous.
Yes. How to know if it is instantaneous and how do we know if it is permanent dipole?
Because there's what you call it, electronegativity between the halogen and the carbon alkynes thing.
Yeah. Yeah. Yes. Is correct. Okay. So on this the reaction. So I think we can finish the class earlier, so you can have time to study. At least you can study in 5 minutes. Okay, before the uh, time for the physics. Okay, so good morning, students, and we will discuss again on Monday.
Thank you, teacher.
Okay, thank you, Chair.
Yeah.
Thank you, teacher.
Yes.
Have a nice day.
Have a nice day. Have a nice weekend. Long weekend. Okay, stop sharing.